Hello everyone and welcome. In this video, we are going to learn about functions and modifiers in Solidity. So let's get started by creating this owner variable. So this will be the owner of this smart contract. Then let's say we have a struct and this is called user. Let's say the user has a name. Let's say this is unit 8, which will be enough, and age. Now we have the struct. Let's create a mapping, and this mapping will be address to user. Let's say this is public, and we are going to call it users. We have our owner, we have a struct called user, and this user is going to have a name and an age, and we have a mapping to store these users. The key will be address and the value will be the user itself. I want to create a constructor, and this constructor is going to run once when this smart contract has been deployed to the blockchain. And here I'm going to say the owner is equal to the message.sender. I'm saying this owner is the message.sender, and this is the address that has deployed the smart contract. So whoever calls this function, the address of the caller will be the message.sender. So for the constructor, it means that whoever deployed this smart contract. Let's create something else. I'm going to say total balance here, which will be empty in the beginning, but here we are going to say total balance is equal to the message.value. This message.value is actually the value of the tokens that has been passed to this function, like the message.sender, which gives us the address. Message.value gives us the amount of token that has been passed here. But as you can see, we have an error. And the reason is that if we want to accept some payment with a function in Solidity, we need to use the keyword payable. As you can see, after I said payable, we have no more problems. Now, again, this will be just runs once, and that's when we deploy this smart contract. In Solidity, we have two different type of functions, the execute functions and the query functions. The execute functions alter some data on the blockchain. For that reason, we are going to pay gas fees on the execute functions. But the query functions just read the data from the blockchain. They do not alter any data. For that reason, we are not going to pay any gas fees. Let's start with the query function. Here I'm going to say function get owner, and we are going to say it returns address. Now, as you can see, we are getting some errors. So before going to the errors, let's say that this returns keyword is how we are able to return some value from a function. Here I'm going to return some value with this function, and this value is a type of address. So I say returns, and inside the parentheses, I give the type, which is the address. I need to give the keyword that is going to define the function visibility. For this reason, I'm going to call this external. And external means that this function can only be called from outside of this smart contract. We have actually more than one keyword. So we have external, internal, public, and private. External is, as we said, for the functions which is going to call from outside of the contract. Internal means that I'm going to use this function inside this contract, and whichever smart contract inherits from this function can use this internal function. The public means that I can use this inside the contract and outside of the contract at the same time. And also it's available for the smart contracts that are inheriting from this contract. Finally, the private means that only I can use this function inside this smart contract and nowhere else. Even another contract inherits from this smart contract, it cannot use this function. For our convenience, we are going to use the external keyword. I'm going to use one more keyword, which is view here. View means that I'm actually reading some data from the blockchain, but I am not altering any data. Here I'm going to say return owner. So since I am saying return owner, and owner is a variable or is a value that's stored on the blockchain, I'm actually reading this data from the blockchain. I'm not modifying any data. If we say public, this actually creates an automatic function called owner for us. And this owner function is going to do the same thing that we are doing here. It's going to return us this owner. So whichever variable is public or publicly stored on the blockchain means that it can be called from outside of this blockchain with the same name, a function with the same name. We created this function, but it's not actually necessary. But if I create another function, let's say addition, it takes unit A and unit B, let's say this is internal, and it returns uint. I'm going to say return a plus b. Here we have a warning, and the reason for that is it says you can actually modify this function so it would consume less gas space. Since we are not making any change on the data on the blockchain, like the one before the getOwner function, but this time we are not reading any data from the blockchain. For that reason, here I'm going to call this function pure. The difference between view and pure is that view functions actually read the value from blockchain, but the pure functions don't read the value from the blockchain. Instead, they just work with the parameters and return values. Now, let's create another function. I'm going to call this add user, and let's get the name, age. Let's say this will be an external function. And as you can see, we have an error here. And the reason for that, it's waiting for a keyword from me is either memory or call data. So I'm going to call this call data. This call data means that I am actually not going to alter this name. So I'm not going to make any changes on this name. I'm actually lowering gas fees by saying call data. Again, the call data means that I'm not going to alter this variable in any ways. There are also two different keywords that we can use, memory and storage, but we are going to see what they do later. Here, I'm going to say users message.sender. So this is the one who is calling the function is equal to the user, and I'm going to pass the name and the age, and this is going to create the new user for me. Now that we know there's a new user, it's all good, but the front end doesn't know. For that reason, we can actually make use of events. Let's define our events here. I want to create an event, and I'm going to say create user for the event name. I'm going to say string index name and uint 8h. This event is going to let frontend know what has happened on the backend. As you can see, it's very easy to create events, and it's even easier to use these events. So at the end of my function, I'm going to say emit, and I'm going to pass the event's name. And this is waiting for two variables, the name and the age. Let me correct this. As you can see, I have this index keyword, and this means that I can filter this using this name from the front end, but I cannot filter this using this age because I use the index with the name. I can only use this index keyword with one of the parameters, and choose this wisely because you cannot change this later. This is how you are going to be able to filter your events from the front end. Now let's create another function. I'm going to call this modify age. We are going to get the parameter age here. Let's say this is a private function. I'm just using different keywords here. And I'm going to say user storage user, let's say pointer equals user message.sender. Here I'm making use of this storage keyword, and this means that this user pointer is actually pointing to this variable, and it's not the copy of this variable. So if I make any changes on this user pointer, it's going to actually alter this user's message.sender. So it's going to alter the information of this user. But instead of storage, if I say memory, then if I make any changes to this user pointer, it's not going to be reflected to the original value. It will be limited with this user pointer. And that's why we have this memory and storage. In many cases, you are going to want to use memory, but for this example, we are going to need actually the storage. I'm going to say user pointer dot age equals age, and this is going to modify the age. Again, I'm actually changing the age of this user through this pointer. Let's modify the add user function a little bit more. By saying modify, I'm actually create a modifier. Let's say this is onlyOwner. We can have modifiers with parameters or without parameters. In this example, we are not going to need any parameter. So I'm going to say require if the message.sender is equal to the owner, we are not going to have any problems. But if not, I'm going to say only owner can call this function. And then we are going to put this line. With the modifiers, what we are doing is we are checking if this condition is right, if a given condition is correct. And if it's not correct, we are going to return the error and we are giving the error message here. But if this condition is correct, we are going to the next line, which is the 18th line here, and it's going to connect our modifier with the function. Now let's see how we can use it. At the end of this function, I'm going to say onlyOwner, and this is automatically inject this code to this function. When this function is called, it's going to check if the message.sender is the owner, and if not, it's going to give us the error. But if the condition is correct, it will be go to this line. This line is going to say, okay, continue to the function, and then it's going to continue with our function code. We are going to use this modifier if we want only the owner to do the operation. This is one of the best features actually I love in Solidity, and I use this a lot. My recommendation is you can actually use this require inside the function without putting this inside the modifier. But my recommendation is if you are using the same require in a more than one function, then I think it's better to make this a modifier. Now let's see how we can actually retrieve some tokens from a function. For this reason, I'm going to make use of a library. Here, I'm going to import this reentrancy guard from OpenZeppelin, and I'm going to say this contract is reentrancy guard. So by saying this contract is reentrancy guard, I'm inheriting from this reentrancy guard smart contract, and I will be able to use functions and variables inside this reentrancy guard. Now let's create another function. I'm going to say retrieve, and this is going to retrieve tokens. Let's say this is external and onlyOwner. Inside this, we are going to say Boolean success. On the right hand side, we are going to say message.sender, and at this point it should be the owner.call. For the value, we are going to pass the total balance, and we are going to finalize our call. On the right-hand side, we are going to make this call, and this is going to transfer the tokens with the amount of total balance to the message.sender, and it can only be the owner. I know this because this onlyOwner modifier. This tuple on the left-hand side is going to catch the values. So we are going to have the success, couple more values, but we are not going to use it. So I just kept that part empty. So this success is going to return the value true or false as the Boolean type suggests, and we are going to use this to understand if the transfer was successful or not. For that reason, I'm going to say require success, and if something was wrong, I'm going to say transfer failed. If this was successful, at the end, I'm going to say total balance is 0. And here you have it, guys. We talked about many features about the functions and modifiers in Solidity, and there are actually a lot more topics that we can discuss. But I hope this introduction gives you enough information so that you can go there and play a little bit with Remix IDE. My recommendation is for you to do so because we can only learn by doing, and this is a delicate subject, so I think it's going to be much better after you give a couple of tries. If you want to learn further, which I encourage you, you can actually find a lot of resources online. But we also created a guide for you, and in this guide, we talked about all the subjects that we talked today, and we also talked about more subjects in more detail, like how you can optimize gas in this function calls and inside these functions. Thank you very much for listening on this video. I hope this was a helpful introduction, and I will see you on the next one.